Good morning, folks. This is NCommander, and for once, it appears that I actually remember to unmute my mic. So, welcome back to what is the second stream, and let me just drop the background audio a little bit. Welcome to the second stream of where we are going to continue trying to resurrect a 1978 Unix. We made quite a bit of progress last time, but that ended up being more of a fact-finding mission than it was actual progress. So let me bring up the notes. So this is basically where we left it off last time. We made a lot of notes. We found a lot of good research, and I did some things between streams, and I just need to hit the start recording button because I'm thinking that I will actually edit this into a full video, so because there's enough here that it's worth doing. So where we left off last time is we were using the Raspberry Pi on the serial terminal to emulate the PDP-11. From the feedback I got, I think I'm going to use the beginning of the stream to talk a bit more about the PDP. I want to talk about RetroFuse, which I was linked to after the last stream. And I also want to talk about the Linux NCP project, which I also got linked to. So I also learned a few more things about the disk packs and so forth. So I'm kind of going to just throw out everything we did yesterday, and we're going to start from scratch again today. But we're going to move forward with purpose. Is something wrong? Am I muted? How am I muted? Testing 1, 2, 3. No, I see the bar going. The stream died. Is it completely down? Okay, all right. All right. There is something going on with Comcast. I have to call them and get a tech to come out. I don't know why, but I am in fact dropping packets. Like, I can see in OBS that I am dropping frames. Hopefully it will not be as misbehaving as it was yesterday. But yeah. So anyway, where I want to start off with is I actually do want to talk a little bit about the PDP-11 because I kind of glossed through this originally. The PDP-11 was made by Digital Equipment Corporation. And the PDP-11 was probably one of the most influential computers. I mean, this was made from the 1970s. When was it introduced? 1970 exactly, actually. And it was continued into 1997. I mean, there's probably still PDP-11s in active service today. Which, considering it's a 16-bit architecture, really says a lot. The real mode 8088 processor actually has a lot of resemblance to the PDP-11. I would say they're actually about equivalent in terms of performance. Well, I would say an original PDP-11, the later ones were faster. There were 36-bit, because that's how DEC worked, PDP-10 machines, so the number going up doesn't change a lot. The PDP-11 was a mini computer, which basically there's no real good equivalent for this day and age. The best I could give you is like a shared host, which would serve a small number of users compared to a larger mainframe like a System 360 or a CDC 9000 or similar. So that's the basic backstory. PDP-11s would have both magnetic tape and paper tape. Magnetic tape was just known as that. I believe the paper tape was called the DEC tape. But please do not quote me on that. This has been an incredible crash course in learning everything that DEC actually did. So the big thing that we ran into last time is the stock Unix distribution tape assumes that it's working with what's called RK05 DEC packs. These are essentially a giant floppy disk. Each one holds 2.5 megabytes, although some of that space is used for swap in the default configuration. And if we looked at, we found when we were looking through a lot of the historical documentation we were looking for, one of the PDP machines that were being used for development used two RK05 drives, one for the root partition and one for user accounting and temporary files, if I remember correctly. And then this was combined with what's called the RP03 disk drive. It's not actually a DEC part, although DEC apparently did make some. I thought there was a photo here, but yeah. Basically, this is a large multi-platter drive. You'd plug it into the DEC, and then it would actually be shared across operating systems. Partitioning in Unix is entirely hard-coded, something we kind of ran into the hard way. Like if we go to the, I guess RP works. You can actually see here the partition table is completely written and hard-coded. We did manage to boot off an RP03 device, but when I took a closer look at the system after the stream, we didn't do it. It got screwed up. I don't know if I formatted wrong or if I just went through so many files, but I didn't do it correctly. So that's fine though. So, and then there's something we do want to support, and we may actually have to do this to get this working. And this is the replacement for the RK05 drive. This is the RL01 and the R2. We found a driver for this buried in the source code of the Network UNIX, and I have seen this driver in a few other places. The RL01 is a 5 megabyte drive, but again, it's a removable cartridge. So basically, the way this would work is that when the system was supposed to be running Unix, and they would actually switch the disks out, like if you needed to run DEC's proprietary operating system, which was, well, not proprietary, but there was, like, if you need to run TOPS 10, if you need to run RS11, they would physically just pop the disk out, pop another disk in, and if you were lucky enough to have one of the really big disk drives, different groups of sectors would be used. You know, this was how it was used. And this was actually described, I don't know if it was in this link, but I know I've had read like how some some labs, like they would say these hours we'd be running Unix, these hours we'd be running a different operating system. So that was more or less how it was done. And to answer some stream questions, Alexi, I did not do, most of this is from just a lot of reading. I mean, I got to the start of my junior year in college, and then I got a job offer I could not say no to, so I didn't. And it's more or less been going onward from there. And then this was the last thing we explored at the end of the last stream. This is the giant, this isn't complete, but this is sort of like the de facto graphic people pull out that showed the family history of Unix systems. So we're right here in the very early days. This is Unix version 6, the first one that really escaped Bell Labs. Version 5 had some distribution, but V6 was the big one. It was the one that, V6 was before my time, but one of the big things that I learned computing from was actually reading the Lines book, which uses the V6 source code. It's not the best in this day and age, but I still highly recommend it if you have any interest in this period. One of the things I've been wondering about is it is possible, based off some of the comments I see in the source code, that they were actually developing this on Programmer Workbench Unix. Because, and unfortunately, PWB Unix has not been well preserved. It's essentially a fork of V6 that adds a bunch of programming tools. Let me actually grab the Wikipedia tab, because oh, actually, I already had it open. Let me just drag it up here. The big things with Programmer Workbench, and this might be a different stream, it was the first Unix It was the first Unix to have source control, actually called source code control system. I don't think it was, well, maybe it was the first one, because I mean, Wikipedia right here says it was the first one, but again, that's Wikipedia. I assume there was, no, that, maybe, I mean, this would predate Files 11, but I think mainframes had their own types of version control. It also had remote job entry, and again, it also has its own shell, the PWB shell, which again predates the Bourne shell. And then a few other things like trough. CPIO would be a really nice one to have, as well as grep commands that actually like are useful, as well as yak and lex. So it's a pretty big step forward, but I'm not completely sure how necessary it is, especially for what we're trying to do. It may, like I said, it's worth looking in a different time, but there is no complete surviving copies, unfortunately. So that's the good or bad. And why is my stream, why is it complaining about bitrate on my stream? Oh, I did lower the bitrate a little bit just because the internet was being interesting. All right, so, oh, hey, Goff Alice. It's great to have you at one of these. So this is what we learned last time, and then I had some really good Twitter conversations. So if we load up, or actually, I won't load this up in console. Let's grab the GitHub page because this is actually really cool. I don't know how I did not find this when I was originally looking for it, but someone wrote a fuse module. And I will drop the link in chat if my mouse, you know, I really should get the external mouse out. Why am I doing this with a trackpad? Someone wrote a fuse module that can actually mount most, if not all, of the ancient Unixes. If we look in the source, this supports V6. It supports V7. It also supports the Berkeley Fast File System, quite a few versions of it, both 2.9 and 2.11. So this solves the file transfer problem that we ran into. We did figure a way solving it yesterday with period correct tools. I'm not going to torture myself that badly. Not on a live stream. If and when I make the video on this, I will describe on how I would have done this with period correct tools. But it's not worth the suffering. I mean, I'm not going to do it to myself. Not this time. Not unless like I don't know, like a few hundred in super chats drop in. Hint, hint, nudge, nudge. But by and large, this is going to really help. So I believe the system I want to build here is we're going to build 2x RX-05 drives. One will have our root file system. One will have the Unix source code on it. We're then going to set up the RPO3 drive with it, and we're not going to bother with trying to copy files to and from. This is going to be our main build directory. If I have to load files from the programmer's workbench, this is where it's going. The one thing I am concerned about is I am not sure that the RK05 drive is actually going to be large enough once we build the network stack. And we are going to have quite a hurdle to get there. We are going to have to go through and actually clean up most of these source files. It's not the end of the world, but it's going to be exceptionally annoying. There's no clean script, and I do want to make sure this will actually build from source. And then we're going to have to merge some drivers. Like, I want to merge in the RL driver because that would give us a much larger root file system with avoiding all the problems with the disk packs. So, yes, and to answer T King in chat, I have tried it. It does appear to work. I have not tried it extensively, but this makes our lives so much better. Because otherwise I was going to have to try and either get CPIO working and hope that there's no compatibility issues, or I was going to have to try and get tar ported. There was just a whole lot of pain and suffering to be had in all categories. That's really what it boiled down to. So with that being said, I think we should start building a new system. Now, I'm not going to use the terminal right now because we did this like 5 times yesterday. So let me open a new console window and let's make it nice and big, so you can all see it on stream. Yep, that's good. All right, and then all we gotta do is SSH into the Pi, and there we go. So let's make a new folder, and let's call this day 2, and then let's start making our bootstrap. So if we go to, let's see here, do I have it? Yeah, I have it on the other browser. No, wait, that's V5. Do I have V6? Yeah, I do. Right. Come on, drag. There we go. So we're just gonna run through this really quickly. I will commentate as I go along. So the first thing we're going to do is we need to boot from tape to the bootstrap program. So let's grab this, and you can go down here because I don't actually need you. And this is going to be our tape boot. And then let's change the drives. So RK0 is going to be our root RK0 file. RK1 is going to be Unix source RK0. Then we want to set RP0 to be an RP03 device. I believe that's how you do that properly. And then we want to attach RP0, and then this is just going to be disk, I guess big.disk, because it is large. I mean, that's about all we can say. Then just past this is the program that you have to key in to be able to do anything. This is be punched in. It basically sends a command to the magnetic tape to reset to 0, and then load load one block to address 0. At which point we can then do the actual bootstrap. So let's do it. So PDP, I have to add to the path. Path, home, and ancient Unix, source, simh, bin. Let's not script our path. PDP-11, tape.ini. Okay. Yes, and override last track. Let's see here. Invalid argument. Oh, why didn't you like that? Okay, so we did all this, and then it got... Oh, did I do the PDP-11? Oh, right. Some version of the PDP of simh do not like having comments in this file. I ran into this in testing I did off camera. And because the last few times I've typed this in by hand, not this time. This time, we have the full power of copy and paste, things that you kind of only could have dreamed of in the 70s. All right. Cool. All right, so PDP-11, tape.ini. Actually, I have to copy the tape to this directory, but yeah, that's fine. All right, cool. Now it's happy with that bootstrap program. Let's grab the V6 tape, and let's put that here. Okay. All right, so now we've come this far. Now we just tell it to jump to 0. And there's the installation prompt. So this is how we copy the images off the base tape and onto the system. So we need copy from magnetic tape to an RK disk platter. Oh, I'm typing at a little bit of a weird angle. So 0, 100, 1. That's the boot sector. 101, and oh, helps when you type it right. Okay, disk offset is 1, 101, 3999. All right, and that is copying the root file system over. So that's going to just take a little bit, and I'll actually make this a bit bigger just because we've got lots of screen real estate. Cool. So that's everything we need to just start up in single user mode. So we don't need the tape. Let's make a single.ini. And then this entire part goes away. We just need to set the system register to go into single user mode, and we want to boot from RK0. Okay, so single. All right, and then we need to boot from RK Unix. And there we go. Restricted. Well, and then. Oh. And now we have lowercase. It's a miracle. Whew. It would be nice to have blinking lights, but I have no idea how you'd like emulate those. All right, so I'm actually going to drag this browser window to the bottom screen just so it's not like constantly coming up. Yeah, and then we can just close all these windows because we don't need them. That goes away. One thing I do miss a little bit from Linux is macOS's window management does not make me happy. It's nowhere near as nice as what I could do under Linux, but a lot of it works so much better. Okay, so let's change directory. Actually, let me move my microphone slightly because that'll give me a little bit more typing space. Change directory, user sif conf, make config, and let's change the track. Let's see here. You know what? A chip tune sounds really good right now. Okay. All right. So move this to make conf. And now we just need to give it a config file. Talk about speed running this compared to like the last time we did this. So M40S. We might want to switch that to a different model because the M40 is the machine bootstrap. And we could emulate a more capable PDP-11. Actually, we need to change the config because we do need... was it RP or HP we were going to need? Because HP was the high performance one. I think we were going to go with the RP03. Let me just make sure I put the right driver in there. HP. Yeah, so it's RP that we actually want. So, so we actually need to change the config file. So, so RK, the first one has to be the root device. Then that would be RP. TM is the magnetic tape. I'm not actually sure what TC is. I think that's the port multiplier, and LP is the printer. Okay. So now we build that. A.out, M40.0, C.0, lib1, lib2. And now we have a valid and working Unix system. Now let's make all the device files we're going to need. Or, well, I shouldn't say all because we're going to need a few more beyond this. But being able to copy and paste that is really nice. Okay, I don't have Vi, so I have to remember that. C.C. If I want the RP, not the HP device, but if I want the actual RP, okay, so that's node 1 as a block device, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 1 and 11, which, like, I should have known, but that's fine. All right. And then, okay. There is a, so catching up again with chat, there is a known RL02 driver. I'd have to go fishing for it. It's not in any of the distributions I have on hand. It's known to exist on some of the historical disk packs. So, there's that. So, make note, make node, RP0, block 1, 0. Make node RRP0, character 11, 0. Cool. So now the next thing we got to do is we got to copy over the source tape, because that will have all the bits of Unix that we, you know, care about. Okay, I don't need that window. I feel like I need like 3 more screens compared to what to actually get anything done. At times, like, it gets a little bit ridiculous at times. Here we go. So here's all the character devices. So I'm not going to bother with the documentation, although it's not the worst idea in the world to, like, grab that. So we want to read in from the magnetic tape. We want to write out to the second RK05. We want to write 2 megabytes, and we want to skip the first 2 megabytes and change. And just be really happy that this doesn't run at period correct speeds, because we'd be here for probably half an hour. Because what I think I want the end goal of this project is I want to build an actual distribution tape for Network UNIX. So other people can actually try using it without going through all the hoops that I am currently going with. Assuming I can, you know, actually compile and install it. That's not good. Why did that read error? Magnetic tape. Is the tape not in there? No, the tape should be in there. Okay. Let's try that again. Dev MT0 RK1 count 4000 skip 41. Unless the tape is in the wrong position, but I don't see how that could happen. Unfortunately, I can't just go look at it and see what the tape is actually doing. I'm not sure if it's actually doing anything or not. So yeah. Nope, that time it actually worked. Okay. Not sure why it didn't the first time. I'm just going to accept this. Okay. Yes. I should note that I do have a hard stop, so I need to go run into Manhattan for an errand. So we're probably going to end this between 1 or 2. I could go as late as 3, but I kind of don't want to, like, drive myself crazy. And I have a pretty good idea of where I want to take this today. So there's the Unix source code. So if we mount that... I might patch that. There is a fix for it. Mount dev RK1. Yeah, so there's all the original Unix source code, as you can see here. There is a documentation section on the install tape, but we don't need it. So I'm not going to use it. All right. That is not the right window. That is, you know, I'm just going to close this entire tab because I don't need it. All right. So Now that we've got that restored, we could really just append the mount command. Like, we don't even need to pull out ed. Dev rk1 user source. Normally, the next step at this point would be to patch the df command. But I don't think I'm going to do that. I will, however, enable multiple terminals, because I do actually want to take the system into multi-user mode. Okay. Unfortunately, oh, no, I didn't spell that right. So for those who are wondering, this is how terminals are defined. Each one of these is like the terminal, it determines if the terminal is enabled, and they're called typewriters in this version, hence TTY for teletypewriter. Right, save. And now I think we are good to go. I could attach a line printer, but I'm not going to bother. So let's copy our single Unix. And then I think we just got to get rid of that one. And I guess, I mean, I can just copy and paste it in. It doesn't matter that much. PDP-11 Unix in. And hopefully if I did this right, we will get a login prompt. Or, well, first we'll get the... There we go. Now we have Unix installed. So let's set up the big drive. And to set up the big drive, I just need to know its partitioning information. So I think all we need to do is this is the magic number. So it uses pretty much all of it. Let's see here. It'll use 20 megabytes, which is ludicrously overkill for what we're doing. Makefs /dev rp0, and then that will write the free list. This is going to take a moment. A good time to look at chat. Okay. Block size is 512. There's no MT command. Well, maybe there is an MT command on this version. I actually haven't checked. Okay. So, all right. So now we just let that format. Then we need to patch the df command. And I think at that point, I want to make a backup. Because if there's one thing I've learned, hugging thy backup is always an incredibly smart thing to do. You know, I just had an idea. And once this is done, I'll implement this idea. I can be typing on the laptop and still have the camera pointed at the glass terminal, which I think has a really nice aesthetic. So I think we're going to do that. I have to shut the system down to do that. This is taking its sweet time. Sometime today would be nice. I mean, it's literally got one CPU core pegged, although I think SimH always does that. So, what have folks been up to this weekend? Because apparently I'm just going to be killing time here for a bit. Like, anyone do anything fun? Yep. I'm hoping this hasn't, like, died. Like, well, I can, you know what? It's a multi-user system. We can check this. 127, let me SSH into the Pi again. Like, I can just do this. Oh, I think something died because I'm not getting a terminal. Let me send a delete. I think it went down. Yeah, I think it went down in flames. Let me see here. Let me just let it. Yeah, it's stuck in some sort of busy loop. Oh, F. What happened? Does it? Let's see if we can boot. root. Maybe that was a too much file size? We seem to be okay now. All right, let's look at the code again, because we did like partially figure this out last time. Like let's just try 40,000 and see if that's happier. Dev RP0 40,000. And hopefully it doesn't crash this time. Like on the real system, I could look at the operator panel and I would know what it's doing. But here, I can't see that. Like, I have to take it on faith it hasn't crashed. So reading some of the comments. Bring your own storage. I really do like... Goth Alice, that's kind of like a really awesome project for bringing your own storage. We really do need more alternative to S3, because... basically, everyone's copied S3 and all the things that go with it. I mean, I use B2 myself for backups, and I don't have a lot of good... Like, the price is right, but I also have a lot of bad to say about it. There are ways to simulate it, but from everything I've seen, you actually have to have an operator's panel. Yeah, I think it's got stuck in. I think something has gone... wrong here. Oh, Unix. So we have a drive. We have a disk attached. Oh no, maybe we don't have a disk attached. Look, non-existent parameter. Did I may have screwed up the config file. That may actually be what the problem is. Attach RP0 big disk. Let's get the SimH manual. Let's see what I'm doing wrong. Because when in doubt, read the manual. So here's the simulator manual. Let's make it nice and big. And what we want... Oh, that's right. Okay, I remember this now. I remember. You can't emulate in RP03... with SimH. It's not supported. Or was it not? Was that the problem? Yeah, it's not. Just to make sure. Yeah, it's not actually supported. That was the problem we ran into last time. Okay. Okay, not the end of the world. So let's change this to an 04. Let's toss the disk image, PDP-11. And we'll just reconfigure. Actually, before I do that, clear screen. And the reason we're going to do that is terminal, and then we can do a Control-C. Like that. And then we can go back to doing this. PDP... That's kind of neat because I am typing on the laptop and it's just getting copied across. All right. So we need to reconfigure the boot kernel, which isn't hard. Just it's more annoying than anything else. Let's see here. So we need to make config. And then I just need the list of things that we put in here. Okay, installation. Like, I should have this memorized. So we want RK, HP, TM, TC, 8DC, LP done. And then now we can relink the kernel. And hopefully we still have enough memory on the system that this is not going to be a big problem. If it is, we'll get clever. Okay, so LD Okay. A out M40O C.O lib1 lib2. And then move A out to Unix. Cool. Let's make the new block devices. So yeah, this should not have particularly changed all that much. 0, 1, 2, 3, 4, 5, 6. 6. And 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, cool. So now we just need to make the device nodes. Make node dev HP0 block 60. And then I'm not completely sure this is how you would they would have done it back in the day, but it's the closest guide I've actually got. So let's do sync, sync, sync. Stop the emulator. Quit. And there we go. And actually, let me get the face cam back because I just realized that's not been on. There we go. And then Unix. Baud rate is 9600, but it runs a little slower than that. All right, so fingers crossed we will actually be able to do the format this time. Let's grab the HP. So let me look at HP. So for the initial cylinder, actually, let me bring this up on screen. So looking at the partitions, we might want to be on a larger one, because I think we want to probably be on device 4 instead of 0, because device 0 is not very big. Although I prefer this to be 0 index. So let's just try this, and if we run into problems, we know how to reconfigure it. Because if it's not 0 aligned, I have to go through some hoops to copy files in. It's not the end of the world, but it will be annoying. And this is still 5.5 megabytes, which I'm seriously debating if I want to change this. Like, do I really want to tempt fate and try and recompile this? Because that is not going to be a trivial undertaking. Not in the slice. We could try this. This would be partition table 4. I just have to remake the device nodes if I do that. So let's try that. So make node here. And instead of 0, we want to do 4. And then let's see if we can actually format it. And then the size would be... Let's see, the size would be 4,600. Please format. Please don't crash. Hey! Okay, that is actually progress. So now we can add a new mount point. And that actually works. Oh, that is amazing. And then we can add that to ECTRC like that. All right, now we're actually set up to do things. Okay. I don't know how I edited the wrong file. All right. The next thing we gotta do is we need to recompile DF. That is the last thing we gotta do as far as basic system setup goes. Yeah, so there's DF. 1 through 24 list. because we need to change the packs it's using up here. So I want to, what's line 3? 2, 4. Yeah, so I want to change line 4, tab dev rk0. I want to change line 5 to that. And then I want to append dev rp0 like that. And then period 2 through 10 list. That was not quite what I was looking for, but we can make that work. Okay, hold on. 1 through 10 list. Delete 3. I really just like need to spend a day just working with Ed so I can get used to this. All right, I think that's everything we need. Let's see here. 1, 2, 3, 4, 5, 6. Delete 6. Write the file. Hey! That works. Cool. After we finish with Unix, on a later stream, I am going to be doing MIT incompatible time sharing. I might do tops 10 at a later point, or possibly tops 20. I'm not certain. The cliff with deck stuff is high. I have reasons for my ARPANET research that I need to go into ITS, but it's not trivial. All right, so now we have a working DF binary, and all is good with the world. So let me sync, and let's shut the emulator down. If it helps if I could hit the right keys. Stop. Quit. All right. I want to make a copy of this. Day 2. RP0 known good reference. Wow, I can't type. All right. So now that we have this, here's the $1 million question. If I... Why is this not letting me type a tilde? Source... retro. Hold on, it would be ancient Unix. Source. Retrofuse. V6 FS. The big disk, and we'll mount it to temp. Temp test works. All right. So here's this. Now we need to put the NOS source on here. And ideally we want to clean it up first, but one thing at a time. Let me SCP over the tarball for it, because this will be what I originally got off the historical Unix stuff. No, Ed makes perfect sense for teletypes. It's just I don't have a teletype. And it's really awkward when you deal with a glass terminal. Because if I had a teletype, I could have line numbers on my actual paper. You know, which makes life a little bit easier. All right, so let's extract all this. So this will go onto... I just saw a permission denied, which is not a good sign. I don't know if those were any actual failures there. Although I didn't want that to extract into the root directory. So, let's do that. Let's see here. Let me just make a source folder. It would have been called source at this time period, so I might as well be correct. sudo tar. Actually, I probably don't need to do it as long as it's not the root folder. All right. So that's all extracting. Yeah. I'm not worried about those permission failures. All right. So let's find all the -o files. And let's just send them right to the bin. If we need some, I will re-add them, but I don't want them to be there if we don't need them. And then let's get rid of... I know there's a bunch of -a files on this. Like that. So I think we're going to send those all to the bin as well. So here's where it gets a little bit interesting, is there's a compile script right here which very clearly has been corrupted. And I've got to actually wait for the terminal to update before I regain control of mine. There is like this compile new, which will probably be the reference that we use, but the syntax is kind of interesting. So we need to do compile for a root directory, system directory, is the directory which the compile be relative, and then load is a different step which generates the final system. So I think root directory will be NOSC source, looking at this. I am not sure. Let's see if we can figure out. So -a is the second argument. So where does that one come from? That is the system configuration directory. And I think that's just the kernel configuration. We can handle that separately. Yeah, you can see right here it does the kernel compile and all that. And the documentation does talk about this to some degree on how you handle this. So I'm not super worried about it as of right now. Like, I just want to see if we can even compile the blasted thing. And then, like, down here, it does all the setup drivers and more. So I think that's not a bad place to go. Okay. Yeah. All right. So let's I say let's just load it up and see if it actually like transferred, because if that works, that saves me so much effort. If not, I'd have to go into a V7 Unix system. I would have to archive all the files into AR archives so I could fit it onto a single TP image, and then I could extract it. Like this would save me probably an entire day's worth of work. So let's see if that actually works as advertised. There are days where I can type, and there are days where I cannot type. Oh, well, that's promising. That's really promising. So let's get rid of that compile, because we know that's broken. And then move compile, new compile. Oh, that actually won't work. It would need to be change mode 755 compile. And then we saw from looking at it that this would need to be this. We actually need a system directory. Like, let's just see what this... Oh, no, actually, no, this doesn't work. This doesn't work. I know why this doesn't work. In the original, we need to go switch back to the external desktop. In the original files, there's this document file that talks about getting set up. We need to update a couple of things here. We need to build a new C compiler. We need to build the Yale shell. At least I think, like, I don't know if this is the same shell or not. But we definitely do need a new compiler. But it's a little... but the thing is that I guess V6 Unix would have shipped with the Thompson shell, and this is the Yale shell. So let's see if we can build any of this. So let's go to S1. We'll do the compile. Well, I guess we should probably do the shell first. Okay, so where is that shell hiding? So there's CC. I mean, if we're here, I kind of just want to do it. Is there a build script? I don't see one, so let's try cc cc.c. Like, is that may be all we need. Or actually, it would be .a out. All right, so now, where is the C compiler on this system? Is it in bin? It is in bin. So bin cc old. And then let's just try and compile something for good measure. Like, let's try compiling df. Okay, I guess that works. All right, so that's the updated compiler. Now we need the updated shell. And the question is, where is that? I'm guessing that's probably in S2. Yep, there it is. So I wonder if -O exists in this version, because that would be a really nice quality of life upgrade to have the -O option. No, apparently it's not in this version. sh.c. Now, the question is, how do I install this? Because I don't think I can... Well, you know, at the beginning of these files, there's always like a reference or a header. Like, if we load this up... let's see here. S2... sh... And here's all the install instructions, and well, that's slightly complicated. All right, I feel like this is a case of where we follow the instructions and we do not deviate, because deviation means death. Because it will brick the system if I screw up the shell binary. So let's just copy and paste it. We've got the updated front end, so there's nothing really bad can happen here. All right. Yeah, you know, you're right. The -O might have been before the file argument. I'm not going to worry about that right now. So we know the compile succeeded. We need to remove the directory, because do we even have sudo? Like, I don't feel like we have sudo. Oh, we do have sudo. Okay. Oh, this feels like such a bad idea. All right, let's do it. Oh, this is just a little nerve-wracking. Move the new binary. We have to set permissions. All right. So far, so good. I realize I didn't make a backup of the original binary, which I really hope I don't regret. Although I can go get it from a different disk image. We have like 6. Okay. And then we do the hard link. All right, and then I am going to reboot the system for good measure. So Control E, quit, restart. Oh, we got a lot. Hey! Well, that's an improvement. So now we have the Yale shell installed, which is interesting. So if we now go back to our compile script, I'm wondering if that's all we actually need, or if we're going to have to go through more hoops. Because this does talk about using like a special shell for all of this, which I don't know if it is or isn't relevant. Like there is a bin sh right here, which I'm not sure if it is or is not the same one. But nothing ventured, nothing gained. So let's find out, and let's move the camera back. All right, and one of these days I will remember the... We'll say we are making progress. Let's just try compile again. So source set not found. If I try like this, are you going to do anything? Or no, it was in the config folder. So that would be in conf sh compile. Oh, that just did things. That did things. So that's interesting. What shell is that then? Obviously, it understands things that the other one doesn't. Like I can do set, and that's recognized. Okay. That is progress. But I want to understand what that actually means before I start screwing around with the shell some more. Let's go back to... I want to look at this. So this talks about... This must be run with rconfig as the current directory because the sh and cc needed are special and are kept there. Question is, do we have the source code to this special -sh? Like, if we go down here to S2 and I type set, is this recognized as a keyword anywhere? Okay, so it is actually recognized as a keyword, but is it... If equals cp1 set... I wonder if I didn't successfully upgrade the shell, but let's follow the instructions here and switch to the config directory, because this... Oh, wait. Hold on. Did cd just work? Am I going... I think I'm just going crazy here. Okay. Yeah, I'm just going crazy. That's fine. Nothing new there. So... Alright. If I do compile like this, what happens? Set not found. To compile the files, make config, is config, and sysfix must be in the right, it's source, not source. Okay. So what happens now? Well, it's doing things. Obviously, I don't think this is working, but I want to see how far it actually gets. Also, is my chat not updating? Like, I haven't seen a message in chat in a while. Yeah, so it's just going to generate a whole lot of dummy modules. Well, that was interesting. That was completely not what I was trying to do, but please, hopefully it didn't like litter .o files everywhere in my file system. No, it didn't. But what went wrong is the bigger question. Module not found, dummy module included. So where did that error come from? Let's look at the source of the config script. All right, so external display, VS Code. All right, so couldn't create default config, so we basically skipped this entire part. And then it runs this compile script for, or compile. Where does temp compile end up? So here, go to setup. So that goes to start it. There's this reconfigure script, but I don't think this actually helps. Let's get some syntax highlighting, so maybe I can see some stuff that I'm not seeing. Okay, shell script. Like, see, I don't even recognize this syntax because this is this is before the modern Unix shell was ever even created. So this is way, way different. Okay, so here's dummy module. Where's it getting? So it gets module not found, dummy module included. And it gets that from argument D. I really love all these like magic. So you give this the root directory, the system directory. System directory is the directory in which the compile will be relative to. System directory may not be load. So what is root directory? So root directory becomes R. And then it does a shift, so all right. Let's try this. Let's make a new directory called build. Where are we? I am curious. Source. If I try something like that, what happens? Let's switch back. Moment of truth. Does that do anything interesting? Sort of. I kind of feel like I have to make this SH the system SH because breakage. Or actually, I think I have to actually be in the config directory. So SH compile source. And then that just completely falls over. And then hit delete. All right, I think we're going to have to make some modifications to this. Because obviously we need a bit more debug info. So these steps complete successfully, and then it goes to... Let's look at the errors, because this will give us some idea of how this is actually running. Yeah, so it builds these two, and then there's no output. So see, it runs that command, echo, and then it goes here to Unix compile code. And then, so we see that here, and then we see module not found. I don't really understand what this syntax is trying to do, though. Like, I've never... Let's see here. Timeshare batch syntax, not shell script. Yeah. Let's just look at the original one, because the older one had hard-coded paths. Maybe that'll give me a hint. But I have that distinct feeling. Like, yeah, see, this one has all the hard-coded paths, which probably was used with an older version of the shell, which might give me some hints of what this syntax does. If anyone knows where I could find documentation, it would be very welcome. So this version... No, this one also runs this compile. I don't think there's a -x option. I mean, flags were not a big thing in this era, but it could exist. I'm just going to very quickly skim the source code to this. See if there's anything useful here. Main... Yeah, basically... it has a dash... Was dash E the echo in this era? I feel like it was. Like, if I do... I really want to say dash E was, like, how you told it to do echoing in this era. Versus dash X, which is the modern one. But I'm not convinced. Yeah, that's actually how you do it. Okay, that sort of helps. Yeah, no, because that's showing me the variable expansion. Okay. So it runs this command. And then it starts looking for yeah, so these are all the files it's looking for. So maybe I'm invoking this wrong. Maybe I have to do it not like this. Like if I do it like this, what do I get? I get a whole bunch of module not found. So module not found. I think I just need to put a PW. I think it. Hold on. Where am I? So I'm here. Let me move up one directory. just to humor me, I want to see what happens. Look, okay, that actually did it. So you have to run it from the top level directory, and now it's actually running the compile. That is amazing. It is actually building. Can we get some hype in the chat, please? That is actually building. Look at it. That is 78-year-old, not 78, sorry. Nearly 50-year-old source code being compiled for the first time. I will note that there is no path. There is no environmental variables in this version. Look at that. All right, I'm going to step away from keyboard for a moment so you can all watch this. I'll be back in a moment. All right. I'm back, and I just saw the bad. So, symbol table overflow. Didn't we install a patched version of, you know, CC to fix this? Yeah, I mean, there was definitely some failures here, and there's a lot of other stuff that didn't build from what I saw. What else did not actually build? Okay, so part of the DMR stuff did not build. Compile failure. Yeah, so it basically fell apart while building the kernel. That's kind of what I expect. Well, I shouldn't say that's what I expected, but so here's the thought I'm having. I don't know if it's a good thought or a bad thought. Let's take a look at, let's look at the source code here. Desktop. If we go back to our installation note, which is not here, it's getting set up. So we definitely made progress. Let's just reread this. To get going, there's a number of things that must be done. First, the vanilla C compiler does not have a large enough symbol table for some of the network modules. A new C supervisor is in s1cc.c. This should be compiled and installed. I'm guessing this part was relevant. Other C modules that were changed. Check with Glenn. But we don't have a Glenn. We do have a copy of the CC they were using, though. They did include it. So that might be what we just want to try using right now. I'm not thrilled about that, but it is an option. So, and yes, this is code that was, I don't think Ken and Dennis directly worked on the ARPANET stuff, but I mean, they did most of this. Okay, so now we've got a whole lot of like .o files in this folder, which I really don't want, but that's fine. I can type. So what did we actually get out of that? So, I guess it probably built in this folder, I guess. Like, if I go into... It wouldn't be in there. It would be, like, in DMR. I could type. Wow, what happened to my typing ability? You know, let's just try their compiler, and then, okay. Deep breath. I can still do this. Does this compiler work? That's the first question. Like, if I tell it to build, what do we have in here? Make config. Yeah, so this compiler does work. So maybe I replaced the wrong compiler. So it's in there. So let's just try this. Because if it's a compiler issue, then it means that some of the patch source code is not correct. All right, so conf, or no, that's not how we want to do this. sh compile source build. All right, let's see what this works. Well, it's building the compile. It's building stuff. Hopefully this compiler is usable. If not, we're probably going to have to... trying to think of what we'd have to do. We'd probably have to use the V7 compiler, which isn't the end of the world, but I really don't want to go down that rabbit hole if I don't have to. Because I know they were using it in some places. But I don't know if the V7 compiler would just compile as is, or if I'd have to go through a whole bunch of hoops and such. So, giant question mark there. Alright, so far so good. I believe the numbers it's printing out as it's going is the segment table, so you could debug this on paper. I think this is where it errored out earlier, so I think we've already gone further. I mean, can you just imagine doing this on a teletype in the 80s? Or I should say late 70s? You know... Ooh, that's not a good sign. Okay, so DMR TTY died. Let's see if we have other failures. That might be a... There were known corruption issues on this disk, but that file is not a critical failure. Symbol table overflow. Damn it. I feel like we had less errors, but I don't think that was what we could call a success. Alright. Let's look at this. First thing, I want to see what's going on with that TTY file, because that's concerning. So that if that's just corruption, I'm not going to really worry about it, but all right. So what lines? Oh yeah, that's bit corruption right there. I can see it. Do we like how? Is this different than the stock driver? That is the million-dollar question. All right. We'll come back to that one, but we know that, let's add that as a note. So DMR, TTY, byte corruption issues. All right. And then the other one let's just see what's going on in that file more than anything else. NCP kernel drivers. Let's see here. So that would be, where would that be? Kernel drivers. And that would be here. And it died on line. Oh. Okay, so we do actually have some corruption. We have data corruption here that we're going to have to fix. Like, that's not... That's not a bug. That's actual data corruption. I mean, it doesn't look horrible, but... I mean, this is very... I'm trying to figure out how this would generate an FF. Like, there's a note at the in the root directory called John's note. After a grim fight, I got all the files off your tape. Yeah, so there was definite problems. And here's the infamous Greg again. I don't know if this is done when the tape was archived or if this is a period correct note. It looks like it's just form feeds, but it is concerning. Let's just... Okay, so here's how we're going to deal with this. Let's do a search. I believe there's a way I can tell it to search by hex. Well, I know there is. I just have to remember how to do it. Like, I just want to search for this one character. It's not letting me copy it in. Can I do find all occurrences? You're really not going to let me do this, are you? Like, can I do something like that? Invalid regular expression. That's going to be annoying. Does anyone know a good way I could find all these easily just for corruption stuff? Yeah, I probably should just use sed. I just have to remember the sed commands I'm going to actually need. Sed match byte sequence. Okay. Wow, that's just going to be really annoying no matter what I do, really. Because well, I guess FF would never be a valid character in this case, but... Okay. So select it and press Control F. Yeah, no, it's not doing anything. I mean, I've seen a bunch of these files start with a hash mark, although the compiler has not complained about that, so I'm not going to worry. Oh, wait, hold on. Hold on. Okay, so that is actually proof that they were using the programmer's workbench. That's an SCCS ID. So if we need to go looking for bits, that tells me where to go look. So that's actually a really important implementation note. NCP code was developed at least on part on AT&T programmer's workbench. So that probably has like the updated shell. Actually, well, we saw when we were looking at it earlier that programmer's workbench has an updated shell. It has the PWB shell. So not the end of the world. Okay. Yeah, let's see. Let's grab a hex adder from... Let's see here. So let's grab hex adder. Hex, come on. So that's grabbing. Okay, that's installed. And now if I want to open... I'm going to have to figure out how I'm going to do this for... All right, so hex edit. Now, can I do a find in here? Like, can I search for FF? I don't think I can. Let's see here. Oh, the bots are back. The bots are back. Hold on. Oh, okay. Rich Wareham, thank you. That actually makes it much easier. It's like my brain is like struggling to find the ability to wait, to deal with this. So let me clear that out. And then let's see if that works the way I'm hoping it will work. Yeah, using TR should be that's a really clever. I should have thought about doing that myself. That is a really good trip. Not a trip. Something I'll be able to use in the future. All right. So print. And then if I just run the file through it. Am I in the wrong folder? Yeah, I am in the wrong folder, actually. Oh, I know what I'm doing. That didn't quite work the way I was hoping it was going to work. That kind of removed all the white space. Like, I'd like a little bit more white space than that. That's hilarious, but not actually useful. Translate characters. There's gotta be a way I can make this a little less stupid. That's funny, though. Yes, we'll give you all your printable characters, white space for the grand total of 99, 99, 99. Okay, that's looking a bit promising. Let's move the original out of the way. I'm gonna have to like go through the Git repo and fix this properly, but although it looks like that just stops a little bit short, so hopefully it's not going to be a problem. All right, so this is now complain that you've changed. Okay, hold on. Close you all out. Am I in the wrong place, or is this... What version of the code am I looking at? Am I like in 3 different places? Open folder. Oh, I'm probably in the downloads version of this folder because of course I am. Open folder. And yes, I trust the authors of 50-year-old code that they have not accidentally put malware in my build. All right, so if we go here, did that? All right, and then let's rerun this command. Okay, that looks like it did actually get rid of all the corrupted bits. Oh, wait, I just saw one. That one doesn't really matter, but I mean, This is pretty damaged. It'll work for now. I'll figure out a better solution in the future. Oh, wait. Wait, hold on. Does the file really just cut off there, or was that... Oh, the file does just really cut off there. That's a problem. So the question is now, how much of the file is actually missing? Oh, that sucks. That's an actual corruption issue. Probably no one noticed it because no one's ever tried to compile this code from scratch. It's not a complete deal breaker. We could put stub code in and probably put in the missing functions. I mean, it doesn't look like there's a lot missing. Let me see if this is actually used, but... Oh, that is going to be incredibly depressing if that is in fact the case. Yeah, so that is in fact... hold on, let's back up a little bit. Where are you actually used, and do we have a second copy of this that we can take advantage of? Because sometimes this code gets, like, copied in 3 different places. So there's the symbol and the configuration symbol. And then we can see where it's used. Looks like there was an earlier version of it in here. Like, are we... Oh, we're not that lucky, unfortunately. My thought here is we stub this out for now, and we'll figure out what other missing functions we have to deal with. So this, I think, is a void function. Yeah, returns nothing. So we could just do that, and that will at least be valid C code, if nothing else. So we... That's a blow. Okay, so function missing. Let's add that to the notes file. Where is the notes file? Okay. Yes, I trust the author of this file. So functions missing wow, that was a typing fail. Functions missing imp IOC. But I think we can work with... Okay. So we now know we have actual corruption issues. So let's... Why did it go all the way back to the top? Okay, hold on. Let's go into DMR. We know the TTY driver was corrupted, but we should just be able to copy that from here. Let's see here. I want to say we'd be able to copy it from here, but maybe... Oh, maybe it was in user sys DMR? Yeah, okay. So we can just copy this version of it like that. The other one is going to be a bigger problem. Okay. So NCPK drivers. And then we want to replace this with the version we're going to copy in. Paste without control characters. Okay, now we still gotta wait for... Uh-oh. Okay, so maybe copying this into screen was a bad idea. Yeah, okay, I think I crashed it. I think that's the emulator has tapped out. Yeah, it's not responding. Because of course not. Why would it be that easy? Alright. Oh, and then no. Stop entering commands. Stop entering commands. Stop pasting. Stop. Terminate. Okay, so let's not copy and paste files. I mean, I'm really hoping that didn't do anything stupid. That was fun. That was fun. Okay, so let me make sure PDP-11 is not running, and it's not. Let's mount the file system, and we'll just do this better. Retrofuse, V6, FS, blah, blah, blah. Big disk. Cool. And then we can copy this one over. Cool. And then if we go here, source, drivers, we get rid of this one. Like that. And then actually, let's just make sure that that's actually... it shouldn't care about the lack of missing new line, but, you know, let's just add it. So it's something I don't have to worry about. Like, it really should not care. Yeah. Like, modern tools do, but most old ones don't. Okay, unmount, or let's get out of here. Unmount, test, and then let's fire it up. Actually, I'm not running in screen, so let me get this running in screen. Okay, all right. So far, so good. And then we want to run Unix. It's a little, it's a little harrowing at times. Okay. Cool. Now we got the terminals synced up. You know, I'm actually going to type on here because I just like typing on the Model M, and I might as well enjoy myself. Source. All right, so compile. Let's see how far we get with this. Oh, the bots have returned. Fortunately, I can look at it right now, so report. I will put the server on must be subscribed. It really kills interaction if it starts becoming a real problem. Okay. Report, and then hide user from channel. I could do an ASMR stream, maybe for like last year on Christmas, I did a very chillax stream where I just went through a bunch of my old computers, and that was a lot when I really started focusing on making the streams much more enjoyable for myself. Right now, the streams I'm doing right now are all going to be research for my next video. I was really hoping I could... Well, it's not a lost dream yet, but I'm really hoping that I'm going to be able to get these utilities to compile. But so far, this is looking promising. So we know that, so we know there's some definite corruption issues here, but how bad it is, we'll find out. It's like every time we see a build failure, we can assume that there's some code corruption. Okay, that's not a fatal. That's me being a freaking turkey. I know what's wrong with that one. That one is an easy. That one should be a straightforward fix. I'm not gonna say it's gonna be an easy fix. Let's see how far else. You still failed on 151. Why did you fail on that? Symbol table overflow. Okay, hold on. If I do NCBK drivers. Here. I just want to compile this file by itself. The missing symbol table, that is quite a bit of an annoying problem. My brain is thinking I kind of want to just keep going, and then we'll come back around and figure out what else is or is not missing. Let me see here. So let me look back at the compile script, because maybe the thing to do right here is, let's see here, external desktop, and if we look back at compile, this is what we're building with. How far are we actually getting? I really wish I could make this remember to be shell, although it's not super accurate. So we get through the kernel, we get through the resident, it goes through the device driver, and then, I mean, there should be more modules here it's trying to build. So where does it actually die on us? Last archive library. That's the load it command. Like, does this not build like all the other implementation code? So here's where it builds the driver. So no driver. And then it starts looping. I just noticed we have more like stuff down here representing file damage because, you know, of course. Although just random nulls I'm not that worried about as compared to like a bunch of other things that could be down there. What was the exact failure? Like, what, I shouldn't say what the exact failure is. What was the last line it put out? It was the last line it put out was done. Is it like not actually trying to build anything beyond that? Which is entirely possible. Yeah. So that's probably this line right here where it did the done. Yeah, because this is where it builds checksum and trace. And then it just exits. Like, how does it get to this setup part? Because that's a label. I wonder if it just doesn't build the user utilities. Maybe it doesn't. Like, if I wanted to build, say, MH, do I have a build utility in here? Because usually there's... Yeah, okay, so that's actually how it's... Looks like it's done. A lot of times there would be these run utilities. Like, do we have load? Like, I'm really hoping we have load. We do not have load. Oh, that's problematic. That's actually problematic because we don't have those utilities. So what I had seen in the original source code is... Yeah, sorry, in the Unix source code, there were run scripts. And actually, I think I can show one of them. Like, if I go to... yeah, that's not going to work. Yeah, so if I go here... You can see how there's these various run scripts, and these are what are used to like rebuild the entire system from scratch in case of emergency. Like if we do the S1 run, you can see every set of command being used like that. There are run scripts here for building the individual commands, but we don't have that load command, which is a little concerning. Let's... Oh, wait. Hold on. I just noticed something. I just noticed something big. We have the source code to load. Execute CC on argument files, compiling those that need it. If... Oh, this is like a very, very early version of make. Compiling those which need it for each file argument. If file was modified since .o, the file's passed, and it prevents having to recompile. Oh. Wow, the bots are really out in full force. Yes, I find it amusing that it keeps trying to tell me to help with things that are very, very old. So let's see what else is here, because obviously we're going to have to go... I think we're going to have to do some hunting. I think I would have to I think the thing I would need to do is merge all the source code from the S1, S2, and S3 folders and recompile. We probably also need an updated copy of CC, which obviously I don't think I have, but let's just look a little closer. Yeah, I'm not seeing an updated copy of CC. Like, there's a few things here, like account logging, which is not in the original. Oh, actually, it is in the original. I was wrong. Like, iFix. This fixes inodes. We probably have this one. So your make password. So I probably would have to merge all of this and then compile it. And then the kernel is probably handled by a separate process. So let me just see what else we have here. So we have the server daemon. Yeah, and look, you actually have... You have a lot of build instructions about this. So... What's the takeaway on this one? Let's build that load command, and let's see if we can actually build some of these utilities. All right, let me switch the camera, bring the camera around. Camera terminal. That was in S1, I believe. All right, so CC. I do want to try this. Like, I don't think this would work, but it's worth trying. Yeah, I didn't think that was going to work, but it was worth trying. So that gives us the assembly out file. All right. So now we should, theoretically, if I want to build, say, let me look at these in the other command. I think we could build all of these fairly easy. Like if I wanted to build the MH stuff, but I didn't realize, is this the same MH that like we use in this day and age? I mean, I think it is. All right, let's see if we can build any of this. So we want to do delete.run. Well, that's a lot of things that just kind of broke. File not found. Libh, libg. That's probably stuff. Yeah, that's stuff I did delete. I'm guessing we probably need it. Do we have a way to build that? That's a bit depressing. I'd have to copy it back in. Which probably means that there's more missing bits, which... joy. Yeah, so there's this libg, which I had deleted because I wanted to clean out all the... go back to here. Yeah, so if we look at the commands that build stuff, you have the static library G and H. I have no idea what it is. We have maillib. We have the binary objects for this. We just really can't do anything with it. Let me just look at all the run files just to make sure we don't have it. But we do not. Okay, so at a minimum, we need libg, libh, and maillib. MH needs following objects. Libh, libg.a, and let's see here. What was the other one that we needed? Maillib. We do have the source code available, or binaries available for this. That's up here in bin. I believe these are like all the ones that were actually used. Like if we do something like show, cannot install MK definitions. Can I do send? Oh yeah, you can't actually see that. Let me move the terminal window. Yeah, so these look like these are all the commands from MH, which it's probably trying to install in my home folder, which I don't have one. Let's just... I'm curious. Where is that coming from? Like, if I do... MH definitions... Where do you get installed from? Here we go. So you get installed by a file called install definitions. So, all right. Not great, but so be it. Install definitions. Do we have this utility somewhere? So prior to using MH, it's necessary to have a file that contains information to direct certain stuff. Get RUID. This looks like this is a standalone utility, but it's not. let's see if we can compile this from scratch. cc install defs.c. And we got a whole bunch of missing functions. Do we have a run file that generates this? I don't think so. It doesn't look like it gets built anywhere. All right, we'll come back to this one because that is actually fairly interesting. It's just, you know. And here again, I'm seeing missing files like, oops. So I think the mistake I've made, so the first mistake I made was deleting all the object, or not the object files, the .os, but deleting the .as, because it doesn't look like we have all the source code to them. Which is unfortunate unless it's buried somewhere else in here, which, I mean, it could. But bugged daemon, that's a great thing you really want to see here. Offset utility.c. Yeah, so again, we're seeing more SCCS stuff for our source control. And then over here, we have a bunch of network control programs. We have the server daemon and more, which I don't think we were going to be able to run any of these. Yeah, because you can actually see, this is actually this is fairly old code. This goes back to 76. They were working on this for quite a long time. I do find it interesting how they were doing network host resolution through devnet anyhost or dev.net. Like, there should be a dedicated hosts file somewhere. But without being able to compile certain components, it's easier said than done. And you can see how parts of this is all hard-coded. Not like, well, look at that host name, Univac 1110 or 100,000. 1110 is the easiest way to say that. Probably a lot of these utilities are, I wonder if these are obsolete, actually. So ARPANET mailer daemon, when were you? No, you were being updated as late as 79. So these are definitely being used. Okay. So over here we have, I actually kind of want to try and build the FTP client. Although I'm seeing more corruption issues, which is really unfortunate. All right. Like, if we tried to build this as is, that was not the commands I wanted to run. Okay. Yeah, I know that we need a C compiler supporting more symbols, but I don't know if we actually have one. Like, is that something we can just fix with compiling it in? Like, if we go, we have the source code to the C compiler. Let's just take a peek, because it's literally one file. So cc supervisor for the C compiler, symbol size. Is that like all we actually need? Is to bump the symbol size? Maximum number of defines permitted. You know, let's just try it. We got nothing to lose. Because at this point, I'm kind of just brainstorming over here, figuring out what we're going to need to do to, if possible, move forward. 47. Change. See here, and I don't think it's going to need. I'm going to try 1,000 first because I don't know if we actually have that much memory. All right, so cc.c, which didn't quite work the way I intended to. How do we build this? Oh, apparently that I screwed up with the syntax somewhere. So I'm going to go 46. 46 through 50 list. Ah, yeah. So 47 change. Oh, how do I get to put the hash mark in? Do I have to escape it? Okay, apparently I do actually... Yeah, I have to escape it because it's treated like a backspace by the shell. That's a new one. That's admittedly a new one for me. Okay, that seems to be actually happier. All right, so if I just want, yeah, I think I can just copy a out bin cc like that. Make sure it still works, and it does. So if I try this again, compile. Let's see if it dies with that same symbol compile error. I think FF may be... I mean, I'm not certain what the FF is, but let's take a look. I'm going to re-extract the source code, and we're going to try this a second time. I mean, obviously there's some corruption in that one file, but I don't think it's a fatality. I just feel like we're going to have to build all the utilities and such, which is going to be a fairly tedious process to say the least, but not the end of the world. But we do know the source code is not 100% complete, although I will investigate that a bit more. I just mostly want to see how much of it can actually be built. Still going. Fingers crossed. So, NCPIO. So we're going to have a failure here. That's expected. It's going to die, yeah, right there. The question I'm wondering is it going to be able to compile imp.io or impio.c? Symbol table overflow. So, all right, let's try a 10,000. I kept it low because, again, conventional memory is a concern, but it's not that much of a concern. cc.c. All right, so 47 change. Like, is sim size the only one I need to change, or do I also, or is SI, Okay, SP size is the max number of characters to allocate for strings. Sim size is the max number of defines permitted. And then this was, looking at the source code here, that was how, originally from Bell, revised 77, 79, and then you have the whole thing here. Let me see what causes that overflow error. Internal, let's see here, symbol. What was the exact error? It was symbol table is not defined in this file. It must be defined somewhere else. It might be defined in one of the other files? Question mark? Is your overflow? Yeah, that's not defined actually. Okay then. So where is that defined if it's not there? The music we're listening to is from Stream Beats. The track is called Spelunking. Oh, yeah, you're right. I did actually get that wrong, although I don't actually think this file is going to help because this is not where the error is coming from. Hold on. Let's look at the documentation. What was it else did it have to say on the subject? If we go to doc, we go to setting up. First, the vanilla C compiler does not have a large enough symbol table for some of the network modules. So it must be expanded. A new C supervisor is an S1 cc.c. But I don't think that's everything we have to modify. All right, hold the horn on this one. Let me pull up a copy of the V6 Unix source code. Unix V6 source code. Because I think we're going to need the entire tree, because I think we have to change parts of the C compiler, which is not a thing I'm really looking forward to doing. So let's grab this tab and let's bring this up here. So if we look at C, this is all the bits and pieces of the C compiler, like each of the runtimes. And this handles like all the lexing and such. And looks like there's like a master header file. Like here's pass 1. So if we go onto the actual system itself, and let me switch OBS so you can see what I'm doing. And I grep for table overflow. Okay, so there it is. Symbol table overflow is defined in C00. So what? So let's figure out how that's done, because obviously we're gonna have to do some work here. So symbol table overflow, and this is defined by 2 symbols here. And that's the symbol table size. Where do you come from? Symbol table, okay, hold on. Some more grepping is needed because this is probably a global variable. Yes, it is actually a global variable. It is a global variable defined here in, where was it? It was actually in Z0H, like I thought it would be. And that is called, it's called HSH size. Yeah, so it's defined on line 14. So I think we can do this. 14. I'm going to set it to 500 just to see if it actually makes a difference. And then can I just do the run command here, or do I? Yeah, I can just run the run command and that will rebuild the compiler. All right. Hopefully that works. All right, so that's going to recompile the C compiler. Wow, we've already had to patch our C compiler. Talk about a process. All right, so that's building. So assuming this works, then I just have to fish out a better version of that tty.c file. And I shouldn't say a better version. I should say a less broken version with less corruption and stuff. Okay. Yeah. So it's seeing what's changed. So, okay, so now we've got that. And one of these days, you know what's going to happen is I'm going to start typing chdir on my day-to-day, and it's going to drive me completely crazy. All right. Let's see what that comes out to. And I've just sat on my keys. I'm guessing, yeah, it's hash. I mean, I don't remember what the unique identifier was back in this time period. It could have very easily been 6 characters where the unique was as unique as symbols got. Because, I mean, memory is pretty tight on the PDP-11. I think base configuration was just 16 kilobytes of usable space. V6 Unix needs more than that, but I'm pretty sure that's how it was sold from DEC. Okay. Okay, so Linux, the Historical Society has a version of that file that is not corrupted. That is actually really good news. We can take full advantage of that. That's weird because that's where I grabbed this, but I grabbed it from the tarball. I didn't grab it from their source control. So maybe someone's fixed it in the intervening years, or it got typed in again. So that's a good place. That's a good thing to know. I will say that if I make a video on this, it's going to be a really, really fun and sort of complicated one. Okay, so yeah, we knew that file was going to fail. That was expected. No, not video memory, just memory. There is no video memory on this system. This type of display, the PDP-11 has no type of knowledge about that. Because this is a line terminal. Oh, it built. It built. We actually fixed it. Oh, look at that. It actually built. That is a thing of beauty. That's it right there. ImpIO found as, and there's the symbol. I believe this is instruction, data, and symbols. We're not building with symbol information on most of these files. Nice. Oh, that is a thing of beauty. So the next step would be to run the load it command, but let's go see if we can actually dig up this potentially fixed. And we're going to have to reload some of the source code back in. So I'm not super worried about losing this. that is good to know that we can actually do that, though. So, what did we end up as an end result of that? Like, did we end up with, like, files here? Well, yeah, I don't think we did. We still have Unix Greg just, you know, kind of chilling over there. Okay, so let's actually figure out what exactly we got as part of that process. That is a really exciting win. So if we take a look at, so if the Linux Historical Society, so I know they have it. I just have to find where it's buried. I think I actually have the link in my notes. Let's see here. Was it here in the Unix tree? This is probably close enough. So let me grab this, pull this up to its own tab. So this is basically as many of the surviving early Unixes that there was. So it should be listed here. So here's 7th edition Unix archive. We're looking for NSOS. Here it is, early networking. So if their version of this code is good, that is interesting. So what were we looking for? So we're looking for NCP kernel, drivers, and then why am I not? Am I in the wrong folder or? Is it not there? Okay, hold on. It's in BBN V6. That's a much later release. I didn't even look at that because that's TCP/IP. That's almost like, that is a much later era than this. But it does make sense that they still had the NCP kernel code in there, because when ARPANET was built, the way it works is the PDP-11 was attached, or I shouldn't say PDP-11, whatever machine was connected to ARPANET was connected to a secondary machine called the Interface Message Processor, or IMP. And they talked their own wire protocol that was known as the 1822. And then the IMP to IMP protocol became known as the network control protocol. It's complicated. So this is actually from a completely different dump. Like, this is not even the same code. We do have the identification string, so let's see if that's the same one that we have. Because, all right, so because if that's the same one, then that's problem mostly solved. I think it is the same one. Yeah, it is. Okay, so it doesn't look like the file has changed, but it looks like only the headers. So if we grab that missing function, like the very bottom of the file, and we don't need all the smileys in Mac OS X, and we go look here, that is an amazing find. That is like a huge win. Oh, come on, work with me, browser. Nope, not that window. Help, I'm lost in a sea of windows. Which is weird because I'm on a Mac. Here we go. That's the file I needed. So if we look for IB-GET, is it down here? Yeah, it is down here. Oh, wow, there was a lot of this file missing, apparently. If this is where it actually cuts off, that was all the file. Look how much file was actually missing. But I am seeing preprocessor definitions, which, were there any, were ifdevs used in this era? I mean, we'd be able to reconstruct it from the missing code. Yeah, like this has definitely been modified. Like if defined NCP, which would be Network Control Protocol. I don't think it's useful for this project as of right now, but it does mean we could reconstruct it pretty easily. So I'm going to put a link in this. We're going to save this. So, IMP.IOC damaged in original archive. However, newer version of the file exists in BBN archive later. Note, BBN archive use and more. Not perfect, not the end of the world. So let's figure out, oh, did the stream die again? Are we really? Come on, come back. Yeah, I gotta get Comcast to come out here. I just noticed that we're just dropping packets. So the next step that's done is called the load it step, which handles building the new kernel. So where did the kernel pop out? Because we should have ended up with a /Unix when all was said and done. Or actually, that would be under install. Or maybe install did not get run. Yeah, that. Like, did all this stuff compile found? So I think, yeah, so let's look at the old install. So it basically just goes through all the various folders and then kind of build things, but the paths look a little bit different. And oh, you gotta like love these old typos. Okay. Are we back? Yeah, we're back. Sort of. It's going up and down. Why is the bit rate? I'm just going to stop and restart the stream in OBS. Hold on. Are we back? Sort of. No, it's not staying up. I think we're dropping packets. No, I got excellent connection. Am I moving? Well, chat, can you hear me? Let me know if you can hear me. Like, it looks like it's fine on my end. Yeah, it looks like I'm moving again. All right, so let's get back to looking at this. So, people got ads. I don't want, let me run speed test. Speed test is taking forever to load. Okay, speed test says megabits down. 1.2 gigabits down. Tells me I'm having some serious internet problems. I don't know if that's Wi-Fi or something else. I just stopped the speed test. Hold on. Yeah, it's complete fail. Because of course it is. That might be the stopping point for today. I think we're okay now. I've got the green light, and YouTube says I now have an excellent connection. Am I actually back?